Alright, this is video 9 for College Algebra, and we're going to be talking about functions. So first of all, to be a function, we have to be in this criteria. First of all, each element in the domain matches with exactly one element in the range. Okay, elements in the domain, so x values, cannot be matched with two different y values. So I can't have one x value going to two different y values. And it must pass the vertical line test. Okay, here we've got two pictures. Yes, this would pass our vertical line test if we drew a vertical line anywhere through that. This one, if I drew a vertical line, it does not pass because it touches more than one point at one time. So we've got a couple examples, and we're just going to be looking if are some of these things functions. All right, so this first one, I've just got a table of values, and I see that 2 goes to 11 and 2 also goes to 10. So because of this part right here, this is not a function. Okay, for our next one, this is just a mapping. Okay, -2 goes to 3, -1 goes to 3 and 5 though. So because of this -1, not a function. Now, if the line from -1 to 5 was taken out, this would be a function because even though -1 and -2 go to 3, that's okay. We just can't having our x values go to more than one value. For number 3, does this pass the vertical line test? This is where we can look at when we're using graphs. So I don't see any x values that repeat here, so yes, this is a function. And for number 4, this does not pass our vertical line test, so it is not a function. Okay, looking at equations, we can also determine whether or not things are functions by putting them into y equals. So this first one, if we put this into y equals, I get y equals -x² plus 1. Okay, there's no domain restrictions. That's just a normal quadratic. It would look something like this. Okay, and so that is a function. Our second one, again, we're going to solve for y. So first of all, I'd have y² equals 1 minus x², and then I would square root. Well, remember, when we square root, we get a plus and a minus. Okay, and so because of that, this would not pass our vertical line test. We would have two square root functions, one kind of on the top and one in the bottom. So it would look more like a circle. So this is not a function. And our next one, this would be a function if I put this equal to y. And again, we can see this is just a quadratic. All right, moving on to function notation. Function notation is just another way of naming functions. Okay, and sometimes we have lots of different functions, and if we all have them as y equals, then it is hard for us to figure out which function we're talking about. So we name them. So this would be called g of x. Okay, and so we're going to evaluate that function at these 3 different points. Okay, so we're just going to plug in our values for x. Okay, so when I plug in my 2, that gives us 5. And it's really important when we do this that we put parentheses around whatever is squared, or if we have something to a power, that we use parentheses. If you don't use parentheses, you will probably get your answer incorrect if you're typing it into your calculator. Okay, so if we plug in our -3, this will give us -20. Now next part, we're going to plug all of this in, x plus 2, in for x. So anytime we see an x, we're going to rewrite it as x plus 2. And now we're going to have to simplify, okay? And so with this, kind of we're going to quickly do some factoring. Remember, if we square something, that means we write it out twice. So this would be negative x squared plus 4x plus 4. And then I'm going to distribute here, 4x plus 8 plus 1. Okay, if I distribute my negative, it flips all these signs that are in my parentheses. And then finally, we can simplify it all together. And so we just get negative x squared plus 5. Okay, so when we evaluate functions, we can evaluate them at numbers, but we can also evaluate them at values that look more like a binomial. Okay, this next one, this is a piecewise function, and so we're going to be looking again and evaluating. So here we've got two different functions for when x is less than 0 and when x is greater than, and this should actually say greater than or equal to 0. So negative 3, that is a number that is less than 0, so we're going to use this first option. So that would be negative 3 squared plus 1, which gives us 10. Okay, of f of 0, so x equaling 0, we're going to use our second equation because x is greater than or equal to 0. So this would just be 0 minus 1, which is negative 1. And then at 3 is greater than or equal to 0, so we're going to use our first function again, and this would give us 2. All right, so for domains, okay, and this is where things get a little crazy because now when we have all these types of functions, we don't just have our regular all real numbers. Okay, so domains is all real numbers which the expression is defined. Okay, and so we're going to be finding where it is not defined. So we've got 3 different scenarios. So our first one would be if f of x includes a fraction, the domain excludes values that would result in a 0. So if f of x equals 1 over x plus 3, our domain, we would set the denominator equal to 0. So I'd get x equals negative 3. So then our domain would be all real numbers except x cannot equal negative 3. If I plug this negative 3 into my denominator, I'd get 1 divided by 0, which is not possible. So for number 2, this would be for any square root or any even root, really. But the domain excludes values that would result in an even root of a negative number. So for this, we would put what's underneath our root greater than or equal to 0 because we can't have numbers that would result in a negative number. So we need numbers that are greater than negative 6. So for this, our domain would be, we could say all real numbers, x has to be greater than 6, or, so we could say this, or you could just say x has to be greater than negative 6. Either one of those will work. And then finally, for our third type of domain, it's just if we have a real life scenario, we can only have certain measurements, certain inputs, like a measurement. So if I was looking for the width of a cube, I could not have a negative number for the width. All right, and so that is actually it for functions, looking at function notation and what does it really mean to be a function.